All right, so let's look some additional examples. So now, instead of the quantity growing each day by a certain percentage, we're gonna look at cases where it grows by 20% every 6 days, or every 6 weeks, or every 3 hours, not every hour or every day or every year. So if you have an initial quantity, A0, that grows or decays by a factor, this time we're going to call the factor B instead of A, each k units of time, then the formula we have is going to be given the amount at time t is the initial amount, A0, times the factor to the power t, the time, over k. So think about it. If you have 600 bacteria and it triples every 5 days, so not every day. So previously, if it was every day, we would have said, so we had that y equals c times a to the x. This was our previous model. So if you have 600 bacteria, you start with 600 and it triples, a would be 3 to the x. So this formula would be if this bacteria triples every day. But the new problem is that you have bacteria that triples every 5 days. So the formula has to be something different. It is going to be the amount of bacteria is 300 times 3 to the power t over 5. So this models their growth after t days, taking into consideration that every 5 days it triples. So this is our next formula that we're going to have to remember. So your Q is going to be every time you hear that some growth or some decay happens every k units of time. So every 2 hours, every 3 weeks, or every 24 years, then that's your cue to use this formula. All right, so let's solve these. Write a formula that models each situation, then answer the question. So a sample of 5,000 bacteria quadruples every 7 hours. So this is your cue, every 7 hours. So every time you hear something like that, just write down the formula and then fill in what's given. So the formula says that the amount after t equals A0 B t over k. So now, my pen is a sample of 5,000 bacteria. That means that your A0 is 5,000. B quadruples, so the growth factor is 4. And then t over k, your k is 7, because it says it quadruples every 7 hours. So this is the formula that you're going to work to answer the question now. It says how many bacteria are there after 11 hours? Well, you're simply going to plug in 11 for t. So to get the answer, the amount after 11 years is going to be, let's put it in the calculator, 5,000, turn on your calculator, 5,000 times 4 to the power 11 over 7, because t is, make sure you put the exponent in parentheses if it doesn't go up like the plus. So it will be 44,163, let's round it to 1 decimal place, so 44,164. Okay, so that's how much bacteria there is left after 11 hours. Does this make sense? Think about it. When is the bacteria going to be quadruple what it started? Quadruple of 5,000 is 20,000. So then in 7 hours, there will be 20,000. 7 more hours, it will quadruple. So 20,000 times 4 would be 80,000. But we're not looking after 14 hours. We're looking after 11 hours. So just make sure that the answer makes sense. It should be something between 20,000 and 80,000. because at 20,000 it would quadruple what it started, and at 14 it would quadruple 20,000, which would be 80,000. All right, the next one. It says a sample of 200 bees grows by 20% every 4 weeks. Again, your cue is that this growth happens every 4 weeks. So your K is 4 in this case. So you write the formula. A of T equals A naught times B to the T over K. You should write the formula so that you remember it. So the amount of bees, you start with 200, so A0 is 200. Your B, the growth factor, you have to pay attention here. They're giving you the growth rate 20%. So from previous lecture, you know that when the rate is 20%, the growth factor will be 1.2. And then T over 4. And now to answer the question, this is the formula that you're going to use to answer the question, how many bees are there in 12 weeks, which just means that T is 12. So you put that in the calculator and you get the following. So when you put it in the calculator, you see that it grows to 346. Okay, so in 12 weeks, that's how many bees you will have if the growth happens like this every 4 weeks. All right, so if a quantity grows according to the model AT equals A0 times B to the T over K, this quantity grows each unit of time by a growth factor, by a factor of this, right? So if 600 bacteria triples every 5 days, this is what you would multiply the initial amount of bacteria. But it triples every 5 days. So it will go by a factor of 3 to the 1/5 each day. I just plugged in, instead of T, I put in 1 in here. Because, I mean, it grows by something a day. And then the second day, and then the third day, and then the fourth day, and then the fifth day. It's only the 5th day that we know that it triples. But it grows by some amount the first day, and then the second day, and so forth. So to find out how much it grows each day, we simply let T equal to 1 in the B to the T over K, because each day means that T equals 1. So then you can rewrite the formula, and the B to the 1 over K, basically you put it into one number. And this gives you the daily growth factor as 1.2457. And if you want to look, this means a growth rate of 24.57. Remember, when you have the growth factor, to get the growth rate, you subtract 1. So to find the daily growth rate, you let T equals 1 in B to the T over K. All right, so determine the hourly growth rate. For example 1, in example 1, we had, this was example 1 right here. So basically, in the growth factor 4 to the T over 7, I let T equals 1 to represent 1 hour. I'm sorry, my pen is not working properly. So when you put it in your calculator, you get 4 to the power 1 over 7. It gives you 1.292190. 1.2910. So this means that the hourly growth rate is this portion, 29.10%. So it quadruples every 7 hours, but in an hour it only grows by 29.10. Determine the weekly growth rate for example 2. This is our example 2 right here. So in this portion, 1.2 to the T over 4, you let T equals 1, which represents 1 week in this case. And this gives you 1.2 to the power, I'm sorry, this K should be 4. 1/4. And when you put it in your calculator, you get the 1.2 to the power 1 divided by 4. 1.0466. So that means that the weekly growth rate is this portion, which is 4.66%. So it grows by 20% every 4 weeks, but every week it grows by 4.66.